All right, if you take a look at the equation, sort of right there in the middle of the screen, P equals 2 times L plus W. That, of course, is the formula for the perimeter of a rectangle. It's an example of a literal equation. Literal equation just has a whole bunch of variables in it, and each of the letters literally represents some sort of quantity. In this case, maybe we have ourselves the length, the width, and the perimeter. Okay, so while I could plug numbers in for, let's say, the length and the width here and get an answer, a numerical answer for the perimeter, in this case, what we're going to do is not expect a number as an answer, but to rearrange the variables using some properties of algebra to get another equation. So for example, right now, this perimeter equation, the p's on the left-hand side, and then we have the length and the width over there on the right-hand side. But what if I wanted to solve this for W, for the width? What would I do? Well, there's quite a few things that we could do. We could, if we wanted to, distribute this 2 through the parentheses here. But the problem with that is that's going to attach a 2 to this W, which makes it slightly more complicated, and you'll have to get rid of the 2 later. Why don't I just get rid of the 2 first? What's the 2 doing to these parentheses right here? Looks like multiplication. So to get rid of it, I could just divide both sides by 2. So here's our new equation. Okay, now we're a little bit closer to getting W by itself. So to get W by itself, I just have to get rid of the L. So you ask yourself, well, what the heck is L doing over here on the right side of the equation? Well, it's being added to W. So to get rid of it, I'm going to subtract it over to the other side. And then here we go. And then one last thing that we probably would do is just flip this equation across its equal sign, and that's called the symmetric property of equality, and it just looks like this, that W is equal to P over 2 minus the length. Okay, so all we did was that we took the perimeter equation and then just rearranged it, again using some properties of algebra. So let's try it here. With this strange equation, we've got 3h is equal to big ol' M plus 1/7 RG, and we're going to solve this thing for G. Okay, now what I'm going to do is I'm going to highlight the fact that the G, which we're going to solve for, it's trapped within this whole entire term, which is 1/7 RG. So before we can get G by itself, we have to actually get this term by itself. Here's another tip. The fact that we have a fraction in here makes this a little bit more complicated of an equation to solve. So it would be to our advantage to get rid of the fraction as our first step. So to get rid of the fraction, all you have to do is multiply everything here by 7, because 7, well, there's only one denominator. If there were multiple denominators, you'd get the common denominator. There's only one, and if we multiply everything by 7, it gets rid of this fraction. So let's do that first. So we're going to multiply by 7. It's like a distributive property, so like everything here is going to get multiplied by 7. So the 7 times the 3h is going to make that 21h. Then we have the 7 times, oh, let's bring down the equal sign here. Okay, 7 times the m gives us 7m. And then the 1/7 and the 7, they're going to cancel and make 1, which is the whole entire reason why we multiply by 7. So it's going to be gone, leaving us with RG. Okay, so now, once again, I have to isolate this term first before I can get G by itself. So don't go divide everything by R just yet. Let's get rid of the 7m first. So the 7m currently is being added to the RG. So to get rid of it, I'm going to subtract it to the other side. So on the right side, it's positive. On the left side, when I subtract it, it's going to be negative. I have 21h minus 7m is equal to RG. All right, now we're just about there. The last thing that we have to get rid of is the big old R that's being multiplied times G. It's being multiplied, so for us to get rid of it, we're going to divide it to the other side. Now you can, if you want to, go, divide by R, cancel, cancel. But if you know It's being multiplied over here on the right-hand side. To get it to the left, it's going to be divided. You could just write your answer. I'm totally fine with that. R, and I'm going to flip it over as well. So R is equal to, no, G is equal to, we'll have a fraction on the right-hand side, 21H minus 7M up top, and then our R's on the bottom. There we go. Our literal equation, we just solved that thing for G. Okay, I'm going to look at another couple of examples, and these two involve the exact same formula, which is the circle area formula. On number one, solve the circle area formula for pi, and on number two, solve the circle area formula for the radius, just so that we can see what the difference between the two algebraic processes that we'll have to go through. So let's start with what it says, which is the circle area formula, which is A is equal to pi r squared. Okay, I need to solve this thing for pi. So I look at the pi, and it is trapped in a term that is currently being multiplied by r squared. So I need to get rid of the r squared. How do I do that? Do I take the square root to get rid of the r squared? And the answer is no, I don't. Because if I did, it traps the pi inside of a square root, which is not something that we want. We want to just get rid of the r squared term, which is being multiplied times the pi. So to get rid of that, we're just going to divide it to the other side. We're dividing both sides by r squared, which will cancel it on the right-hand side, because r squared divided by r squared is 1. And then we have our pi all by itself. So let's clean this up and then flip it around to get pi is equal to a over r squared. Like so. Okay, on number two, exact same formula. We've got a is equal to pi r squared, but this time we're going to solve it for r. And this one is going to involve a square root. But before you take the square root, you want to isolate the r squared term first, right? As I said before, if I went ahead and took the square root right now, it traps this pi inside of a square root, all right? So it's kind of like this order of operations backwards. That's what happens whenever we solve an equation. So I need to get rid of this pi first before I take the square root. The pi is being multiplied times the r squared, so I'm going to divide it over to the left. I will have a over pi is equal to r squared. Now the r squared's by itself, and I can get rid of the square. How do you undo a square? You take the square root of both sides, right? Right. Okay, on the right-hand side here, the square root and the square, they're going to cancel each other out as inverse operations, at least when this number's positive. Radius should be positive. Okay, so they should cancel each other out. It's sort of like this. If I had the square root of 6 squared, that's equal to 6. Why is it equal to 6? Again, you can think of these as inverse operations where the square root and the square are canceling, or, you know, whoops, hey, this is equal to the square root of 36, and the square root of 36 is equal to 6, right? So if you struggle with something algebraic when it's just involving numbers, just try something out with numbers, just so that maybe you have a little bit, a different perspective. Maybe it makes more sense with numbers, and that will help you generalize it for the variable case. Anyway, so here, let's write our final answer. I am going to flip this thing around. Like I said, these are going to cancel each other out, leaving me with just r is equal to, and then we have the square root, a over pi. All right, the goal here will eventually be to take this expression and to substitute it into another equation to get rid of the r. Okay, so before we do that though, I want you to take a look at a few of these questions here. So I want you to practice that same exact kind of idea where on number one, you're going to solve the area formula for its length, for its side length, and so on. And then I have another set like right down below it.